Hello, my dear students. Welcome to our Mathematics 9 class. Our topic for today is in Quarter 1, Week 8, and it is all about graphing quadratic functions and analyzing the effects of each graph. To graph quadratic function, you must have the complete table of values of x and y. Much better if the vertex is at the middle, just like in the given function f of x equals 3x squared negative 5, by which the vertex is 0, negative 5. In the function f of x equals 3x squared negative 5, you can get the properties of the given function. The domain or x are the set of all real numbers. The range or y is the y values greater than or equal to k value, by which k is equal to negative 5 from the given example, since a is greater than 0. The opening of the parabola is upward, since a is positive. The vertex is 0, negative 5. The axis of symmetry is 0, and the y-intercept is negative 5. In example 2b, the quadratic function y equals negative 4x squared has the table of values of x and y. Graph by connecting the points with a smooth curve of a parabola that opens downward, since a is less than 0 or a is negative. Given the same given of the quadratic function y equals negative 4x squared, you can get its properties. The domain or x are the set of all real numbers. The range y is the y values less than or equal to 0 or negative, since a is negative value. The opening of the parabola is downward, since a is negative 4. The vertex is 0, 0, or in the origin. Axis of symmetry is also 0. X-intercept is 0, and also with y-intercept, that is 0. Let us analyze the effects of the graph when it is opens upward or downward, narrows and widens, move left or right, vertical translation, and horizontal translation. We discussed already in Quarter 1, Week 7 that if a is greater than 0 or a is positive, the quadratic function is a parabola that opens upward. And also, if a is less than 0 or a is negative, the graph of quadratic function is a parabola that opens downward. This time, let us use the graph of the quadratic function y equals x squared as our guide function, as shown at the right, wherein the vertex is at the origin. If the absolute value of a is greater than 1, the opening of the graph is narrower than of y than the graph of y equals x squared as our guide function. In other words, the bigger the value of a, closer to y-axis. But when the absolute value of a is between 0 and 1, or a is a fraction, the parabola appears wider. Using again the guide function y equals x squared, when h is greater than 0 or positive, the graph moves to the right. When h is less than 0 or negative, the parabola moves to the left, just like in the example, y equals quantity x plus 2 squared. Again, using the guide function y equals x squared, when the constant k is greater than 0 or positive, the parabola moves upward, just like in the example, y equals x squared plus 2. When k is less than 0 or negative, the parabola moves downward, just like in the example, y equals x squared negative 2. Again, using the guide function y equals x squared, the quadratic function y equals x negative 2 squared plus 1, wherein h is 2 and k is 1. This means that the parabola moves 1 unit upward and 2 units to the right. Again, using the guide function y equals x squared, the quadratic functions given is y equals 2 quantity x plus 1, close parenthesis squared negative 1, wherein a equals 1, h is equal to negative 1, and k is negative 1. This means that the parabola moves 1 unit downward and 1 unit to the left. Okay, that's all. To end our lesson, I will leave to disputation. Education is not the filling of a pail, but the lighting of a fire. That's all for today. I hope you learned something about graphing quadratic functions and analyzing the effects on each graph. Bye-bye. Stay safe, everyone.